Hello again. So talking about NATS Surveyor, it's a new way we have for monitoring large NATS superclusters, and just going through the details of that a little bit. It's again Ari Pienaar, you met me earlier, and Colin, who's a product manager for NATS, maintainer NATSnet, and so forth, will do a demo after me, so you can have a quick look at what all this means. So NATS Surveyor, what is this? So previously we had a Prometheus exporter, which would be the classical Prometheus deploy. Next to every server you run the sidecar that exposes a bunch of information about NATS, and that gets sucked into Prometheus, and it's great and it works and it was all lovely. We wanted to, though, improve the deployment process of that, and so that we went to do POCs and large customer deploys and our own large network of NATS, and managing all of these sidecars and things is very difficult. We'll see just now the differences in architectures that this enables, but basically we just want to make it easier to get a view into NATS. You could run this thing on your laptop and see how 50 or 100 NATS servers behave, as long as you have credentials and access to the NATS port, so that's really great. We don't have sidecars on every server. You can run it just anywhere, laptop, Docker, Kubernetes, wherever you like. We ship it as a container. You can even run the binary standalone. We have the Docker Compose helper to get you going. And this requires, and that's 2.0, it requires you to have access to the system credentials. The reason for this is we publish data about the running of the servers, the server names, and things like this gets published across the NATS network and into Surveyor. And so we don't want to have those on just for anyone who uses NATS, and so you need to have system credentials. And the key thing we also support here is service latency tracing, which Colin will go in further, but this basically lets you figure out just exactly how long a certain message takes to traverse from the user to NATS, from NATS to NATS within the cluster, from NATS to the service, how long the service takes to handle a message, and all the way back. And by its very nature, that kind of tracing happens across an entire cluster. And so, it's not really something that makes sense on a per server basis. So we do need kind of a cluster-wide monitoring, and that's what NATS Surveyor is. I mentioned we've done our own deploy, and we've gone to POCs where we try to get people going on NATS, and we're there for a day or 2 or 3 days. And many of you probably work in large enterprises or in telco and the regulated industries, and you're opening ports and you're speaking to security, and you're approving web requests, and the Prometheus deployment model is actually really difficult going on a large enterprise scale. I recently did a 3-year stint at an enterprise, and my very first task was open a port for Prometheus, and I left 3 years later having never achieved that goal. That's just how it is. So we were looking for a way to make that a little bit easier. So typically, with a Prometheus world, you would have your NATS servers. Here we have just 6 NATS servers. And then next to every NATS server, you would run the exporter, which continuously queries the monitoring HTTP endpoint. And that presents to Prometheus the normal Prometheus exporter endpoint. It's just a web server. In every data center, you would run 1 instance of Prometheus, and they would poll the nodes within that data center or that VPC or VCN or whatever cloud technology you use. You would then have a central Prometheus who would aggregate all of this information and present it onto a single dashboard if you want such a thing. This is a lot of work. There's a lot of configuration to be done, especially if you need to secure the connectivity between exporter and NATS. There's a lot of certificates. There's a lot of pain, and there's a lot of HTTP ports. There's a lot of HTTPS ports. So I will just show this quickly. What we do as Surveyor is basically simplify all that down so that you have your NATS cluster, and we have a standalone separate exporter that connects to the NATS cluster and monitor the NATS cluster. The way we do that basically is to simplify all of that is by having a specific subject within the servers that the server will respond with its internal metrics. And so we send a ping to the network. everyone all NAT servers who receive the ping will respond with a big old JSON blob. And that tells us about the connections, the memory usage, the versions, and all this kind of stuff that you will see on the dashboards later on. Additionally, if you are running services across NATs, you can ask Surveyor to sit on your NATs network and listen to these latency traces, and we'll make some nice dashboard of those. And I believe Colin will be showing that exact use case. And so what we wanted to achieve is, once you have NAS deployed, there's no additional ports, there's no additional security, there's no other protocols you have to support. There isn't this HTTP to connect to your brokers, etc. It's just, you have NAS, you can monitor NAS, that is it. And that's what Surveyor does. Now, it's a normal Grafana dashboard fed by Prometheus. We have all the usual stuff, some overview metrics above, cluster-wide stuff, cluster-wide aggregated metrics, and then you can drill in on a per server basis or a per cluster basis. You can see all the routes, all the gateways, and a whole wealth of information. Of course, you're not limited to just the dashboards that we provide, because the Prometheus data is there. You can, in fact, scrape this Prometheus into your other Prometheus. If you already have Prometheus, you can scrape it in there. I've done, for instance, a dashboard where we had a globe, not a globe, but a world map, and we had all lights lighting up all over the place based on how many connections are within regions. And using this information, I was able to do that in like half a day's worth of work. So there's a wealth of information available to you to not just use our dashboards, but also to integrate into your own and build what you need to do. Of course, there's pros and cons to the way that we've done it. It's very simple to deploy. That's great. If you have the credentials file, all you need is the one creds file for a system user. You can run it on your laptop under a Docker Compose. Up it goes, and you have visibility into a whole 100 node network. You can run it really, really easily. And you get not just metrics about individual servers, but about the kind of metric that makes sense to the cluster as a whole. And we'll be adding more of those as JetStream matures. So this kind of monitoring is important in that case. Of course, there are disadvantages. We are using the thing that we're monitoring as the transport for the thing that we're monitoring. And so, if there's a split brain on your network, or if your Prometheus can't access the NATs, or its nearest node is down, or you have configured only with one, you'll have gaps in your graph. So you can do a lot of the data we generate, but I would say, it's not the be all and end all of monitoring NAS infrastructure. So you'll still need some additional tooling that runs, near your nodes. But it's certainly a large improvement for the kind of overview data that you get from it. We have some plans for it. We're really excited about this. It's really made our life a lot easier. As we're working on JetStream, we will be giving you free dashboards of message acknowledgements, and so that is the ones I mentioned in my previous talk, around how long did it take for a message to be processed off the stream, and for how many times did they have retries. And so we'll give you a little free dashboard about your services, and we will also surface in Surveyor how many times your messages are being redelivered and so forth. And also that thing where if it reaches a maximum delivery, so that kind of dead letter queue stuff that will be surfaced within Surveyor. The NAS servers will emit a bunch of events around every person connecting, every person disconnecting, authentication errors, all these kinds of things are there as service events. We hope to consume those and present them as graphs as well. Really good if you, for instance, suddenly see one of your services are going into a reconnect spiral and is doing thousands of connections, you'll be able to see and alert on that quite easily. Right now, you have to tell it, kind of how many servers there are, so it knows when it sends out the request saying, give me your stats. It knows how long to wait for, and so you have to tell it that there's 7 servers or 24 servers or whatever you have. We're looking to improve that a little bit, and community feedback is always welcome. It's on GitHub as everything else, Apache licensed, and we would love to hear from you. Now, I think next up is a demo where Colin will show it. I ran through that a little bit quickly because we're pressed for time. So hopefully we can catch up a bit. That's it from me. Thank you very much for your attention.
You're muted.
There we go. All right. So I'll run through this very quickly. We are running behind. But first, what are we going to monitor? I have this repo that creates a local supercluster. This also speaks to how lightweight the NATS servers are. But on my Mac, I'm going to run a simulated 3-region supercluster, 3 servers each for a total of 9 servers. And then we'll go ahead and get that started. So there we have our 9 servers. Notice there's no sidecars. Now from the NATS Surveyor repo, I've got a Docker Compose file. And let's see. For the demo, I'm going to call a convenience script that I've included. Now I'll dive into this. I pass a URL to any of the NATS servers. I'm expecting 9 servers, and here are the system creds to the NATS server deployment I've deployed. Surveyor the survey script simply takes these parameters, assigns them to the proper environment variables, and then runs Docker Compose. So we're going to start Surveyor. It's running. And then we'll go here and we should be, let me move this. We should be starting to receive data here. There we go. So I've got 3 clusters, 9 servers, 18 route connections, because I've got 3 servers each by 3, and then 18 gateway connections. So this is a full supercluster representing 3 different regions. Right now, we don't see much traffic. What I'll do, I'm going to run a benchmark, run a couple million messages through with 1 subscriber in 1 region and another subscriber in another, subscriber in 1 region and a publisher in another simulated region. So now we're running some metrics through, and we should see things start to take off. Cluster traffic is starting to really take off here. We can see, I can view client connections and what happens there, subscriptions. You can look at gateway details. This is actually gives you a link between each gateway, so you can see which gateways are receiving the most traffic. So for example, region 3A to region 1 is getting 1.18 megabits a second. We have route details as well. Network usage detail. You know, as I ran the benchmark, or running the benchmark, it's increased here. CPU utilization amongst the servers, memory utilization, and then also stats on Surveyor itself. Now what I'll do here as well is let me show you I'm going to use the NSC tool to describe some of the accounts that are here. So I've got 3 accounts in the server: a system account, my account, and my account 2. In my account, I've created a service called help. This should look really familiar as you go through the documentation on services and set one up. This is very similar to what we have in the doc. And I've enabled latency tracking on this. And you can do this when you set up the account, or if an account's already set up or a service is already set up, you can always add this later and enable it. And I've set up latency tracking at 100%. We've got another account, my account 2. Sorry. I've got another account, my account 2, which has imported the help account. Oops. So our help service is intentionally really, really simple. The help service is actually the NATS reply demo or NATS reply example that just connects to someplace in the cluster. I give it credentials, which is my user for my account. So it's responding with, here's some help. So this is going through the service boundary between accounts with that help service. I look at the help request. There's a very, very simple NATS request. Just with localhost 6000, it's representing someplace else in the supercluster. It uses its creds from my account 2 to help and 2 to connect, and it just makes a request. So let's start. The help service. The help service is listening. And now let's start the help request. So I'm sending some requests here. And you can see here I'm receiving the requests. In Surveyor, if I go to Serve Observations, and look at the last 5 minutes, let's do 5 seconds here, we will see the service being latency metrics for the service. So let's add some more requests. Receiving these. And there we go. We're starting to get latency metrics from the service. It gives you a nice histogram of 10th percentile, 50th, and 100th. You can see how many observations are being received by Surveyor. You can look at the percentiles for responder, requester, and system. And between the three, if you want, associate blame, right? Is latency occurring? How much latency is occurring in the NATS system versus from requester end to end versus from responder end to end? So this is really powerful in that I just used the very simple NATS examples. There was 0 instrumentation in the clients, and I simply enabled this in the account, and we're running, looking at what's going on in the service as far as latencies. So I'll wrap this up here. And we'll open it up for any questions.
I don't see any questions at the moment, Colin. Appreciate your demo there.
Sure, really quick and simple, but Surveyor is that way, so.
Yeah, one of the things that I think is really important as the general ecosystem starts looking at a transition from static monitoring types of systems with dashboards to the notion of being observable or observability. I think the key point that I'd like to point out is that Surveyor is already based on an observability pattern. You know, inherently pub/sub systems at their core are inherently transparent because there can be end-to-end communications. And so what's happening is all of our servers by default have a system account which is locked down and secure, but can respond to requests of saying, how are you doing? I can either target one server or lots of servers. So we already are doing that type of thing. And what Colin was just showing is the notion of service latency. And then, there's a lot to understand and learn there. And it's coming from the notion of like service mesh types of functionality. But what we found is that with these massive superclusters and global networks, service latency is not a single dimension. It's actually 4 dimensions. And so the system that he was just showing you is actually in real time reporting dynamically on all 4 dimensions, meaning how fast the responder could respond, how far away was the responder to the NATS server that it's connected to, how far away is the requester from the NATS server it's connected to, and optionally, how far is in between the two NAT servers from the requester and the responder. And as you start growing larger and larger systems, as we're seeing with a lot of the users and customers that have been working with us, right? That notion of a single dimension service latency just drives them nuts. It's like, this is just too limiting. And so what Colin was kind of giving you a little bit of insight into, we think is extremely powerful. So good stuff.